This will be our final lesson for Chapter 2, where we are graphing functions, essentially. The last two learning targets that we got, number 15 and 16. Number 15 is use operations on functions, so we'll be doing a lot with function notation there. And, of course, you know operations are add, subtract, multiply, and divide. And then the last thing that we'll look at is evaluating composite functions. So I'm pretty sure from one of our previous conversations in a lesson that you had some funny name for this. So we'll see if that is the same thing. All right, here we go. Operations on functions. Well, basically all we've got here is you're going to be doing things like, well, you know what a function is and what function notation is. So it's like f of x. Well, if I had two things, f of x and, say, another function, we'll call it g of x. If I want to do operate on functions, well, that might be something like f plus g of x. Okay? And essentially, all this means is, well, you're going to be taking, well, just f of x and then adding it to g of x. Think of it like, I guess the best way to explain it, maybe thinking about the y values. Okay, remember that f of x is actually replacing y, and so it's kind of the y values that we're adding here when x is a certain thing. And so, you know, we have all four operations. We have f minus g of x. We have f times g, or sorry, f times g of x. And then we have f divided by g of x. Okay, a lot of times, instead of x's here, we'll actually have numbers. Sometimes we'll just have the numbers. Sometimes you'll be looking at functions on the Cartesian coordinate grid. Okay, so that's basically what we've got with operations on functions. We're going to be adding, subtracting, multiplying, and dividing functions. Composite functions comes in a little different way. The way you're going to see this would be like f of g of x. Okay? So this is different than operations on functions. What's happening here is this is actually like saying you've got a function f of another function g of x. Okay? So you remember, like, if I had like f of 4, you would be plugging in 4 wherever you saw the x. So if I had like say f of x equals 2x plus 1. If I said f of 4, well, that means I'd plug in 4 wherever I saw the x. So I'd have 2 times 4 plus 1. Well, if I have f of g of x, well, instead of plugging in something like 4 for x wherever I see the x, I'm going to plug in what g of x is wherever I see the x in my f of x function. You have it two ways. You have the f of g of x, and then you also have, you know, the other case going backwards. You have g of f of x, in which case, you know, this would be the exact opposite. You'd have g, and you'd have f of x being put in wherever you saw the x in your function. So these are the two things we're looking at specifically today. All right, let's see some examples. So if I had two functions, I got x squared plus 1 and 3x plus 5. If I want to figure out what f plus g of 1 is, well, this would be the same thing as like saying f of 1 plus g of 1. Okay? You know, the y value of f when x equals 1 and the y value of g when x equals 1. Well, f of 1 is, I'm just going to be plugging 1 in here for x. 1 squared is 1. 1 plus 1 is 2. And then 1 in for x in g of x. So 3 times 1 is 3 plus 5 is 8. So 2 plus 8 is 10. And that's my final answer. F plus g of 1 equals 10. All right, if I take a look at some multiplication, similar principle here, we'd just be saying f of 5 times g of 5? Well, f of 5, 5 squared is 25, plus 1 is 26. And then if I plug in 5 for g of x, 3 times 5 is 15, plus 5 is 20. Add these two things together, or sorry, not add, multiplying rather. And 26 times 20 would be 520. And that is, again, my final answer. All right, moving on to some similar but different things. I got two different functions here. I've got 8x minus 9, and also g of x is radical 2x minus 1. So kind of same principle here, except this time instead of a number, I keep my variable. So what does this look like? Well, f minus g of x. It's going to be basically like f of x minus g of x. And when I've got that, well, I guess I'm just straight plugging these in. I would have 8x minus 9 minus radical 2x minus 1. At this point, I would combine any like terms if I could. Do I have any like terms to combine? Nope. So that's pretty much it. That's my answer. All right, f divided by g of x. Well, again, I'm basically just going to take f of x and divide by g of x. And so that means I have 8x minus 9 and divide that out by radical 2x minus 1. If you remember some of those pesky rules from earlier chapters, we don't keep a radical in the denominator. Sorry, would have been nice to have that as your final thing. So radical 2x minus 1 over radical 2x minus 1 here. On the bottom, we just wind up with 2x minus 1. On the top, well, we have 8x minus 9 times radical 2x minus 1. All right, so there we go. Next thing. We said earlier that we could apply this to functions, and again, it's kind of like the y value of f of x when x equals 4 plus the y value of g when x equals 4. So we can take a look here, f plus g of 4. Well, f of x, so here's f of x. When x equals 4, f of x is going to equal 9. And then when g of x equals 4, y equals 2. So this would just boil down to 11. Okay. When I have f minus g, it's supposed to be a negative here, negative 2, well, let's see, f of x when g or x equals negative 2, well, yeah, that would be negative 3. Okay, that's something. However, g of x when x equals negative 2, you can see it stops right here at the origin. It doesn't go there. I have nothing to subtract. This is undefined. So I've got nothing for this answer. F times g of 1. Well, when x equals 1, f of x equals 3. Okay, I like that. How about g? When x equals 1, g is 1. So 3 times 1, that would be 3. Final answer. All right, last one here. F divided by g of 0. Well, when x equals 0, f of x equals 1. No problem. When g of x, when I have g of x and x equals 0, it's 0. 1 divided by 0, not happening. So this is another one that is undefined. All right. Let's see here. Moving on. This one has got some great pre-calculus / calculus concepts. You wouldn't know it unless you were looking at it or knew what to look for, but at this point we can just look at it as the advanced version of these types of things. So I've got f of x plus h minus f of x divided by h. And so f of x is this guy here. So if I want f of x plus h, all I'm going to do is I'm going to say, all right, well, I need to plug x plus h in wherever I see the x. So I have 2 times x plus h squared minus 3 times x plus h. Okay, now, so that takes care of this part right here, okay? F of x plus h, I have plugged f of x plus h in wherever I see the x. And then I've got minus f of x. Well, f of x is just straight this guy right here. So I'm going to say minus, now don't forget I need parentheses around this whole thing. That'll change things if I don't. So 2x squared minus 3x. And all of this is divided by h. Now I got 2 variables in here. Sometimes that can make things a little weird. But let's just go ahead and calculate as best we can. We've got a 2, and then I've got x plus h squared. That's one of those special cases, and so hopefully you guys remember that would just be x squared plus 2xh plus h squared. And then over here I've got minus 3x minus 3h. Trying to squeeze things in here, and then I'm going to use the distributive property with this negative sign. That'll give me minus 2x squared plus 3x. I believe this is supposed to be an h. All right, and then all of this divided by h. All right, well, moving on, I'm going to go ahead and distribute that 2 across. So I've got 2x squared plus 4 xh plus 2h squared, and then again minus 3x minus 3h minus 2x squared plus 3x. Whew. All of this divided by h. Well, as I continue working my way down, I do see some encouraging things. I see a negative 3x and a positive 3x. Those are going to cancel out. I also see a positive 2x squared and a negative 2x squared. Those will cancel out. And what I'm left with is 4xh plus 2h squared minus 3h divided by h. Whew, are we almost done? Yes. However, there's one final step, and that is, notice we have an h in each one of these terms, and we have an h down here. That means we can divide everything by h. And what happens when we do that? Well, that goes away. Of course, this one goes away, and that goes away too. And so I wind up with 4x plus 2h minus 3. If you're hoping that there might be a shortcut for this, if you're in pre-calculus or calculus, there is. All right. The final thing here is compositions. Compositions of functions. So here's my f of x, 2x minus 1. Here's my g of x. 4 divided by x minus 1. So we'll do kind of the simple ones first, where I've got an actual number here. I never liked this notation with the O in there, or whatever it is. I really preferred to just go ahead and convert this to f of g of 2. Because it just made sense to me. I got that g of 2, well, kind of off to the side, I'd say, all right, well, what is g of 2? I can figure out what that is. I'm going to plug 2 in here for x, and so that means I plug 2 in there. So I got 4 divided by 2 minus 1, means I'd have 4 over 1, or 4. Okay, so g of 2 is equal to 4, which means if I had f of g of 2, that would be the same thing as f of 4. And could I find f of 4? Well, yeah, I'd just plug in 4 for the x, wherever I saw that over here, and so 2 times 4 minus 1 would be 8 minus 1, or 7. Over here, obviously, just switching it up, g of f of, I believe this is supposed to be a negative 3. All right, well, let's see. This is the same thing as saying g, let's say g of f of negative 3. Okay, so I'm going to go ahead and figure out what f of negative 3 actually is? Well, f of negative 3. I'm plugging in negative 3 wherever I see the x here. I got 2 times negative 3 minus 1. That would be negative 6 minus 1, or negative 7. So f of negative 3 is negative 7. So that means I have now g of negative 7. Well, g of negative 7, that means I'm going to plug in negative 7 right down here. So 4 over negative 7 minus 1 means you got 4 over negative 8, which would be negative 1/2. So you can see that f of g of x is different than g of f of x, or at least the process is going to be different. The last one, you've got an occasion where you don't have a number, you just keep the variable. So f of g of x, that means I've got f of g of x. Well, what is g of x? G of x is 4 divided by x minus 1. So that means in this function, I'm going to plug this whole thing in wherever I see the x in f of x. So that means 2 times 4 over x minus 1 minus 1. All right, how's that play out? It means I get 8 over x minus 1 minus 1. Well, if I need a common denominator, if I'm subtracting fractions, means I'd have x minus 1 over x minus 1. So that would leave me with 8 minus x minus 1 over x minus 1. Minus a negative, that'd be like adding, so I wind up with 9 minus x over x minus 1. And that's how I would do composition of functions. All right, well, that wraps up chapter 2 for us. We're done.